Hi, and welcome back to another maths video. Here we'll be looking at Venn diagrams. A Venn diagram is a way that you can represent information, much like you can use a bar chart or a pie chart to represent information. It looks something like this, with 2 or 3 circles joined together. The best way of explaining how it works is by using an example, so let's do that. So here, I've got a set of data which I want to organise into 2 groups, based on whether it's a multiple of 4, shown by this circle here, or whether it's a multiple of 5, shown by this blue circle here. So first we've got 4. 4 is obviously a multiple of 4, and it's not a multiple of 5, so we know that 4 can go in here. Next we've got 5. 5 is a multiple of 5, and obviously not 4, so we know 5 can go in here. And then we keep doing that for the rest. 10 is a multiple of 5 and not 4, so 10 goes here. 12 is a multiple of 4 and not 5, so 12 can go here. But then we get to 20. 20 is a multiple of both 4 and 5. So what do we do here? Well, we put it in the section that is shared by both this circle and this circle, which is right here. So we put 20 inside here, because it's both a multiple of 4 and 5. And finally we have 17. Now 17 is neither a multiple of 4 nor 5, so we put it outside these 2 circles, out here. But it still has to be inside this box, which they normally give you in the exam. As a side note, the box just contains every single imaginable value, so any value you get has to be inside this. It's also called the universal set, and is represented by the Greek letter phi, which I'm pretty sure looks something like that. So now that we've sorted our set into a Venn diagram, we know that there are 1, 2, 3 numbers that are a multiple of 4, 1, 2, 3 numbers that are a multiple of 5, 1 number that's a multiple of both 4 and 5, and 1 number that's not a multiple of either 4 or 5. Questions that involve Venn diagrams usually also involve an element of probability. So let's have a look at this type of question. So here we've got a Venn diagram representing people that like oranges, apples, and neither. And a question asks us, what is the probability of picking someone that only likes oranges? Only oranges. So first, we need to find the total number of people here. So that would be 10 plus 3, which is 13, plus 7, which is 20, plus 1, which is 21. So the total number of people is 21. Now we come to the actual question. How many people only like oranges? Well, the answer is 10. Now, you could be asking yourself, why is it not this 3 as well? Why is it not 13? Well, this 3 is it also includes people that like apples as well. It's not just oranges. So the people that only like oranges would be this part here, so 10. So our final answer is 10 over 21. We can also write this as a percentage, so you can use your calculator to find that. So we can do the same thing for Venn diagrams with 3 circles instead of 2. So here we've got a diagram that represents what subjects people like in a class. So 7 people only like chemistry and neither art nor history. Right, and we can see that because it's only part of this green circle and not part of either the purple circle or blue circle. 2 people like both art and chemistry, but not history, right? Because it's part of both this purple circle and green circle, but not the blue one. And 1 person likes all 3, right? Because it's part of all 3 circles. Another sort of question you could get is to be asked to put numbers into a Venn diagram based on some facts you've got. So we've got a question here that says, in a class of 24 students, 12 play the piano, 13 play the guitar, and 4 play neither. So, and we're asked to represent that on a Venn diagram, which I've drawn out here. So we're told that 4 students play neither instrument. So immediately we can put 4 outside these 2 circles because no one plays, 4 people play neither the piano or the guitar. So we're left with 24 minus 4 students, which is 20. So we know that 20 people play the piano and or the guitar. But it says here that we've got 12 students that play the piano and 13 that play the guitar. And 12 plus 13 is equal to 25. So how can we have 20 students playing at the same time as 25 students? Well, the key here is to realise that there are people that play the piano and the guitar. And to work that out, we take the smaller number away from the bigger number. So 25 minus 20 gives us 5. So we know that there are 5 people that play both the piano and the guitar. So we can write that in this segment here. Now, we're told that 12 students play the piano. So that means we've got 12 minus 5, which is 7. So we've got 7 students that only play the piano and not the guitar as well. And similarly, for the guitar, 13 play the guitar, and we've got 5 that play the piano as well. So that's 13 minus 5, which gives us 8. So 8 people only play the guitar. Now, you still might be a bit confused, so let me show you. 13 play the guitar, so that's 8 plus 5, which is 13. So 13 play the guitar, but it's not mentioned whether they only play the guitar or they play the guitar and something else. So all we know is that 13 people is inside this orange circle here. That's all we need to know. And it's the same thing for the piano. 12 people play the piano. It's not mentioned whether it's 12 people that only play the piano or 12 people that play the piano and something else. All we need to know is that there's 12 people inside this piano circle right here. So the second part of the question says a student is selected at random, and it asks us to work out the probability that the student only plays the guitar. So if you remember, first we need to find out the total number of people here. So that's 7 plus 5, which is 12, plus 8, which is 20, plus 4, which is 24. So the total is 24. Next, we work out the people that only play the guitar. So that's going to be 7. So our probability of picking someone that only plays the guitar is 7 out of 24. And again, you can find the percentage using a calculator. Now we come on to set notation. For some reason, people find it hard. Not sure why. Set notation basically represents different parts of a Venn diagram. So let's look at those. So first, we've got this little n thing over here, and that means intersection. So we could be asked to represent, say for example, on this Venn diagram, A, N, B, or basically A intersection B. Now this would represent this part of the Venn diagram. So the intersection of A and B. And the way I like to remember it is that you could just remember it as and, so A and B, right? A and B, A and B. So that would be A and B. And what's A and B? It's this part right here. Next, we've got this little U thing here, which means union. And union means or. So if we were asked to draw A union B, it would basically mean A or B. And what's A or B? Well, it's basically this whole thing right here. Everything in these two circles. And that might be confusing, but say I was to pick anything inside these two circles. So say I was going to pick this point right here. That would be in A, or it would be in B. If I was to pick this point right here, that would be either A or B, right? So you can pick any point here, and it would be A union B. Finally, we've got a little apostrophe here, which means not. So if I was asked to shade not A, so that's A with a little apostrophe, that would be everything on here except A, so everything that's not A. So that would be everything of B. Right, we can't shade anything else because that is A. Now let's do a final example. Creds to Colbit Maths, by the way. So first we've got A intersection B. So A and B. So what's inside A and B? Well, it's 9 and 4, right? This segment right here. So it's 9 and 4. Next we've got A union B. So A or B. So what's inside A or B? Well, it's everything inside these two circles. So that's going to be 25, 16, 4, and 5. And finally, we've got not A. So what's not inside A? Well, it's, everything that's not A. So that's 5, 40, and 17. It's everything that's not inside this circle right here. So that's 5, 40, and 17. And boom, we are done. So, thank you for watching another brilliant video. If you liked it, please do like, subscribe, and share with all your friends. Thanks, and I'll see you in the next one.